I know this room is heavily skewed thanks to the topics that we have here around LakeHouses. There's generally a lot of excitement around LakeHouses, as you would know, from the morning session that Vinod did. I know there's one more session that you will have exposure with around LakeHouses, which is E6 data. But this is going to be a very interesting discussion, something that Ananth and myself had discussed once in a podcast as well. But if you've got two real experts who have worked in the Lakehouse world, Ramesh and Ankur. Both of them are here to share their knowledge with you, and Ananth is going to moderate the session, talking about some of the implementation challenges they had and how they remediated it, the challenges and the opportunities and that they see in the Lakehouse world. Right. So, with that, Ananth, over to you.
Hello. Yeah, perfect. Great. Thank you so much for this. Is a session I'm also kind of very looking forward to learn a lot about Lakehouse. We have Ramesh here. I know Ramesh personally for a long time. Ramesh worked for Branch Metrics, where he's leading the engineering team back in the US. They recently did like 8 petabytes of data migration to a Lakehouse architecture. And we have Ankur working for Walmart. Right? We all know like what is Walmart scale is there. They also kind of move towards a hoodie. Yeah. So we wanted to kind of jump in to understand. So we have two big companies who done migrating from typical warehouse architecture to lakehouse architecture. So I'm curious to ask more questions to them to understand what is the journey looks like. Ankur, let me start with the journey. What did the system architecture look like before adopting the lakehouse architecture?
Yeah. I think am I audible? Cool. So in Walmart, is a typical ETL architecture that we have. We use Spark. I'm talking about before migrating to the lakehouse architecture. We use Spark as a computing engine. Our source can be anything. Source can be Kafka, any file-based systems, any databases, and any other things. We extract data from there. We used to extract data from there, and then we used to apply every transformations, all business transformation using Spark, and then we used to write it to some GCS bucket, or that where we actually maintain our data lake architecture, and then we have BigQuery. BigQuery is very popular data warehouse present in GCP. So on top of our GCP file system, mostly columnar file system, Parquet, ORC, we were creating external tables. And sometimes if the if something is very much read optimized, we used to have materialized view, that you can consider materialized tables in BigQuery like the native tables which used to be there in Hive. Instead of external tables, we used to be, after loading from Spark, we are directly writing to the BigQuery native tables. This was the very simplified version of architecture that we were having. We had when we used to use data lake. We still uses in many use cases data lake things. Yeah, but that was the architecture, very basic.
Ramesh, do you want to share about how branch metrics looks like before?
Yeah. Hello. Yeah. So what we had was data lake and the data stored in AWS in Parquet format. And for data processing, we use Spark for batch processing, Apache Flink for stream processing. And then to make the data available to the user, we use Apache Druid for low latency queries for the customer facing dashboard. For finding internal analytics, we use Presto and then Looker for visualization. That's our overall system. Yeah.
Okay, so both of you mentioned about like you use BigQuery and you store everything in Parquet format. You use Presto to query, obviously you use BigQuery to query. Now, those are like well proven technologies, right? Like, and it works for a scale. Were there any, what are the primary challenges and limitations associated with the current choice of the tools that push you to adopt a lakehouse architecture?
I can start.
Yeah.
So the two primary challenges we had, mutability and query performance. What I refer mutability is, if you want if you want to change the data, it's not safe and also not easier. Suppose if you are going to change some data in the table, we need to rewrite entire partition. So we usually take 1 hour of partition and then change it, delete, and then write it. During that process, the reader can see the empty data. In terms of query performance, so the Presto users and data products, they query the data a lot. It's an only data reduction thing we had, partition. So we can reduce the data for each query by partition, not much. So the query is always much slower. Yeah, the mutability and then query for performance is the limitation we had.
Okay. To start with, I will just give you the story why. Let me put it in very layman terms. Why we actually moved and how I convinced my team to move from LakeHouse. So, for understanding LakeHouse, just imagine two different medical shops. Consider one medical shop which is run by a very normal person, normal vendor. So when you go to his or her shops, like medical shops, like pharmacy, you will simply go and you will ask for azithromycins. Okay, when you ask for azithromycins, they will just remember, or they will just search each and every other row, and they will do lot of scanning to find just the azithromycin. Now take the example of well-managed Apollo pharmacy. When you go to Apollo pharmacy, they will not jump directly to the solutions. When you ask that is azithromycin available, they will look into their system first, like their computers, and then they will find where that particular data, particular medicine is actually located. They will go to that particular row and that particular rack, and then they will search it, and then they will give it to you. So this was the same thing that happened with us in Walmart in one of our use cases. That motivated us to move to LakeHouse. So Apollo Pharmacy is just like a LakeHouse, and a normal vendor's medical shop is just like a data lake. In LakeHouse, you have two things. You have Parquet files or any file-based systems, and then you have metadata file systems, which supports lot of good indexings. So let's suppose you are supposed to make any upserts, like as Ramesh talked about mutability. So let's suppose you are having some incoming data, and with that incoming data you have to apply upserts, like update plus insert. So in a typical data lake scenario, what you will do, you will read the data first, and then you will look through your existing database, existing data lake, that where that particular file is actually present. You will make a scan. You can optimize it if you have partitions there, right? That will not look all the partition, it will look into that partition, but that still is a very tedious process. You have to read a whole lot of data just to make an update, and when it comes to real-time streaming, that's a very, very tedious task to do. Like our Walmart does not suppose streaming more than 5 minutes or 3 minutes or 4 minutes. And if you say that I am having update use case where you want to update something, and in typical data lake, if you are using this thing, you will never ever know that where that particular file is actually located. You can optimize it with many partitions and other things, but you have to again read whole data back to your systems using a Spark. You have to apply update there, and you will overwrite the data to the systems. So that analogy, like pharmacy shops, was the main reasons of moving from this to data lake to LakeHouse.
Okay, this is a very interesting pattern I am observing here, because I know Branch Metric is a B2B company and Walmart is like a B2C company here. And like B2B company, the primary challenge is like, how do I delete the data? How do I delete the PI data? Whereas B2C companies are like, how do I update my product catalog as soon as possible, changes, so that we can empower the business here. But it all boils down to like mutating the data in the data warehouse, which is like completely drastic from the whole data lake argument, like everything is immutable. How significant that you see the mutability is here, like plays a role in the modern data warehouse design?
I can answer. So the data, even data we had, naturally is immutable, but there are use cases like we are SaaS company. If one of the customer leaves from us, we need to delete the data from data lake. So to delete in the current way we do, we have to rewrite entire table. rewriting entire table, it takes a lot of resources. It's not also safer. So yeah, that's a reason we got.
I will again share one story with you then. With respect to delete, when I started working, let's suppose you have been given task of deleting data in data lake. And data lake is the architectural pattern, right? You have multiple layers, a raw layer, silver layer, then you have a catalog layer. So, and in data lake, you are typically dealing with the objects. So what happened, there was a typical use case, which was where you might have heard about CGPA, right? That's California rules, where California government can just ask any websites that if you are using my data, and any person can ask and they can say that where you are actually using my data, can you show it? And if they ask that, no, I don't want my data to be used by your company, you need to delete it. So then typical data lake architecture, there are 3 zones, right? And we are engineers. We will simply mess up. We are never perfect. That's the surety. And if you are working with the object like files, what I see that when I started with that project, there was one record written in the Confluence, and that said that this project is related to delete. When I've gone to a stage bucket, that same record was there. That's a very, very big thing, right? So, but when you come from software engineering background, when you are dealing with tables, how do you apply deletes there? You simply update or delete a statement. So I come from software engineering background, and that was one of the first few projects which I was doing in data engineering. For me, it was like, array, somebody has applied delete there, it is not deployed, not deleted also, and same thing is mentioned, that a particular example is there in the Confluence. This is a very big problem. So that is also the things that when you are dealing with tables, you can always have some constant around it, because we are engineers. If we don't have constant, even we talk about multiple design patterns, we will mess up somewhere. So I think that is also one of the reasons why Lakehouse should be considered. Yeah.
That's that's an interesting point. Like, so the bottom line is like a case for adopting Lakehouse is the flexibility that you have in terms of the mutating and like increasing regulation problems, regulation constraints are coming in. So Lakehouse is much better option for than any other solution. Yeah, completely agree with that. Like, I'm just wondering like how is a migration journey looks like. You know, I often joke, what is data engineers all do? Like, we just take data from one S3 bucket and put it in another S3 bucket, right? That's all we do. We don't do much of that, but it's not that as simple as that we talk about, right? So, Ramesh, can you tell like what is a migration journey looks like for you?
Yeah, the first thing in the migration, the foundation of the data lakehouse is file format. We need to choose Iceberg or Hoodie or Delta. That's a bigger decision you have to make. So the way we did POC to evaluate that one. We went with Iceberg that fits our needs. Once you selected the table format, the next step, you need to prepare the ecosystem environment. Any system that touches the data, they need to know the new table format. So we started with upgrading. We are in the Spark 2, upgrade to Spark 3, Flink, Presto, EMR, everything we upgrade to the latest to support the table format. And then finally there comes my actual migration. So we need to find the migration plan. And the way we did, there is a 2-way you can do, one in-place migration or create the parallel table. In-place migration is too riskier, so we went with a parallel table. So to migrate any table, we create the parallel table, start the new write to the new table, and also old also still be active, write is going on. And then copy all the history data from old to the new table, do the validation, make sure there's no issues. Once everything done, update the consumer to the new table. Yeah, then delete finally the old table.
Yeah, the migrations is pretty much same for me also. But in Walmart, the first thing, but company like Walmart, the first thing that before migration, you have to prove your point. Like if you come with, like I can use Apache Hoodie, they will not give you to make change. They will not ask you to make changes in the existing pipeline. They will ask that if new thing is coming, like new use case is coming, you prove it there. Once it is proven, then they will try to figure out that which particular pipeline we can migrate to Lakehouse. Yeah, the migrations was pretty the same which Ramesh talked about.
Okay, I want to a little bit of double down on the migration journey itself, right? Because I used to joke like migration project is the career killer. I know many people lost job with the migration projects. So, like one of the things are very unique to this data migration is like two things, right? One is like both talk about like parallel table creation, and so even though you're creating two tables, you might wanted to run two different scripts, so your code is different, the data that is going to produce is going to be different, and the other nature of the whole data pipeline, which is the curse of data pipeline, I'll call it as like uh, the, the, the time it takes for you to produce a table. Like you are running a hourly job, so if something goes wrong, you have to wait for another 1 hour to kind of fix it and do that one. So there's like the time is one constraint, and the quality of data is another constraint, right? Like how do you make sure that both the tables are fine, like matching, or are you, did you aim for 100% matching or 100% perfection? And what you did for the timeliness of the jobs?
That's the biggest challenge we had because the existing pipeline is stable. All the customer relies on the data. So we need to match 100%. There is no choice in that. So the double write means the parallel table helped a lot. So what we do, we run the comparison pipeline, the another validation pipeline that will always compare both table. The count are okay, and then we spot check few partition. All the data are also same because we cannot compare all the data for all the hours. So we just once in a day, 1 hour of partition, make sure the entire data is the same. That validation pipeline will continuously running until we say, hey, this is everything is fine, cut over everything. Until then, those automation pipeline, validation pipeline will be running.
Have you seen any surprises in the whole journey, or like?
Yeah, always there will be always surprises in the first. Yeah.
Any funny story you want to share?
It's not no, it's not funny story. It's like so we could not match the schema when we moved to Iceberg. We tried to use the hidden partition thing. So we usually in the old table the year month day is the format. In the new table we use the timestamp column, which Iceberg gives the hidden partition. So that's when we migrate, we have to match year month day. Everyone has to query with year month day to this one. During the validation script also, we have to make sure match both columns. There are some issues with the Spark right now handles timestamp with the time zone. So dealing with the time zone always the problem. So we got few issues around the time zone stuff.
Yeah, I always recommend people to use UTC timestamp. Like if your data warehouse not using UTC time, you should definitely
even
quit your job.
Yeah.
Ankur,
Yeah, means according to me, the data engineering pipeline, if it is anything sequential, I call it Chinese whisper. So those who have played this game, they know it, right? So if someone comes to me and say that I want 100% data match, I will be laughing in my mind, and I will be always saying that, okay, I will not commit that I will match it 100% unless I have some source which is persistent. Like I will not play with any source like Kafka where the data is written only for 3 days. I will, because I know this is just the Chinese whisper. Every time you are loading from one source to another, you are actually loading, you can actually miss your data. And if your system, if your first source is not persistent and you are doing migration activities, there are a lot of stories and lot of things that you will face, and that will make your life like a hell. The same thing that UTC and PST. So we used to work with one of the source, and someone communicated that they are rising up in the PST, they need their data in PST, and we made the migrations, we thought it is UTC. And after some times they said, oh, it is PST. Whole migrations, we have to start it again. So that's the typical life of data engineers. One thing that I've learned, make migrations, like if you want to prove your migration first, just check if your system is, first source system is persisted or not. If it is not persisted, just laugh in your mind and just try giving the reasons. Write it to that you may lose data or something. You have to very much on front with the business right from the front. Otherwise, in the end, you all know what can happen.
Yeah, one more question more on the management side of it. You kind of touched upon like we need to prove the point that Lakehouse architecture is worth it, right? Now, how do you get started? Like, if you wanted to convince a management, like, Lakehouse architecture is the ways to go, what do you did?
Okay, so I will take the example for the first time when I moved to Lakehouse architecture. The first thing, I was having one real-time streaming pipeline, and my job was to detect the frauds in Walmart. If say any seller is there, if he is trying to onboard something, our real-time there is rule-based systems for us, which will create rule-based system. Let's suppose there can be offer, and then can be multiple rule ID on that, and then they will send the data to our Kafka. So I just convinced my business that there will be two phases of the development. This was the existing pipeline where we need to move from Lakehouse to data lake. The first thing that I said that I will reduce the cluster timings. In data lake, the real-time streaming, it used to take X amount of time. After using Lakehouse, that reduced to Y amount of time, right? So and Y is lesser than X. So that helped me to convince my business that this is the first time I'm optimizing. Lakehouse is decreasing your time in which you are receiving the data. But now I'm working to, whenever loading data to Lakehouse, when they are reading it, now I'm working to make that reading faster. So for me, I will never commit XYZ MNRP, right? I will always commit, this is the X which will benefit it for Lakehouse, because Lakehouse is very emerging technology, right? We are very, very, very new. We can talk a lot, but we all know that data lake is very proven technology. So I just convinced my business that I'm going to prove X, not Y or Z. When I'm done with X, I will start proving Y and Z. So yeah, that was the way of convincing.
Yeah.
Yeah, so we try to solve our problem ourselves. We put silo solution, workaround to solve mutability and query performance. That become very complex. After a certain point of time, we could not evolve as a platform. So everything takes time to implement it. And another for us is easy to convince. If they daily takes two weeks to 3 weeks to implement it, then how do you improve it? So we said we need mutability support. For that, we have to take this table format and implement it. That became easier.
Okay. Yeah, this is one question just came up my mind. Like, it's a little bit out of sync. When you're talking about a data format, like, it's very important for the source of the data, like what format that you are getting in. So what are the formats that you are getting in? The data is flowing through. Is it like a CSV file or a?
Yeah, again. So the event data comes from different API and then goes through multiple business process pipeline and then ended up in Kafka in protobuf format. So we take the protobuf format and then put it in Avro first, and then Avro is converted into Parquet. So finally it lands with the Parquet. Okay. That's a current format.
Okay.
Pretty much that's the format that we use. File format we use Parquet plus ORC, and then we do read from multiple databases also. Like we might be reading from MongoDB, Cassandra, and mostly we for in Walmart or the company that I have worked for real-time streaming, we always used Kafka. So these are the PT format like we have built. Till now, I consider myself as lucky because I have not dealt with CSV file, neither Excel. That's the one thing. If someone asks me in the interview, a technical interview, that what you want to ask from me, I will say that are you using CSV or Excel? If they say yes, I say no. So because I started with a startup where my friend is there, Neil. We started with one startup where we were creating BI tools, and that I understood. I was having work to detect data formats, like date formats, sorry, and that is so hectic things to do, that just to detect the date format, and it is in CSV and Excel, and company like Excel are using 1996 Excels, and it's very, very hard. So when I moved from software engineering to data engineering, I decided that if company is using, if they say yes in interview, say no.
You have a long career ahead, Ankur. Don't worry about that. Yeah. So this question is kind of nicely slide to like, okay, you did this migration, you kind of incubated, you convinced your management, and you started all this migration journey. What is the current architecture looks like not only the Lakehouse, like what is the entire stack is look like because Lakehouse is one format, like there is a query engine, the BI tools and stuff like that. So like what is the overall architecture looks like?
So in terms of ingestion, we didn't change up to Avro. So we take Avro and then convert it to iceberg format. The iceberg has two data, one metadata and partition. We still register iceberg as a Hive table. So the readers still, there's no difference in the reader. They just access like any other Hive table. And then we added a DBT to create analytical warehouse. So we use the DBT Spark, and that launches, that supports the table format Hoodie or Iceberg. For us, it's Iceberg. So it launched the Spark job and then create the table in the S3 that is registered like another Iceberg table. It helps analytical team to create the metrics, internal metrics or derived data very easier. So now we have mutable data lake and an analytical warehouse. Still, there's something was missing, which is entity data, which is stored in application Postgres table, sometimes the CRM data in Salesforce, billing systems. There are variety of the small data stored across. Without that, we could not create powerful analytics. So to bring that data into Lakehouse, we introduced Airbyte. Airbyte is an open source system that has connector that pulls from these different systems. They also started support the table format Iceberg and Hoodie. So we use Iceberg to directly ingest it. So now we have almost everything. Yeah.
How's the query layer looks like? Like, do you still use Presto or like?
Yeah, we still use the Presto Trino. That Trino has the connector both Hoodie and Iceberg that understand it. We still use the Trino.
Okay, okay. Are you using any BI layers like a Tableau kind of a thing? Or?
So we use the Looker for internal visualization. So Looker is connected to the Presto. Presto still goes to the Iceberg table. That's faster.
Okay. How does the tech stack look like, Ankur?
Extracts, let me put in very simple terms. There are multiple things that we use, but if I just put it, let's talk about the real-time streaming that we use. We use, our source is Kafka. After that, we use a Spark structure streaming as a computing engines to make any transformation if needed. And then we load it to the Hoodie tables where mostly it is observed. And after that, we sync our Hoodie table with the BigQuery. And if someone asks any like data scientist or BI developer, if they want to use our data, we will ask them to connect through our BigQuery tables and they can fetch the data from there. This is a very typical, simple things that we are using right now.
Okay. Let's talk about CSV for some time. So like one of the bigger challenges is like when you are managing this large, like you're syncing from BigQuery and then you are using Lakehouse, stuff like that. Schema management became a very critical problem. Like backward compatibility problem is the hell. How do you manage schema enforcement? And do you find any challenges? Like how your systems look like? Are you just
the old system, we manually manage the schema and then we need to sync the partition to the Hive, which is very painful. After moving to Iceberg table format, we don't need to manage the schema. There is no partition sync in the Hive. Iceberg doesn't store the partition in the Hive. So it's just everything automatically taken care. And schema enforcement, the source is defined in the protobuf format. Okay. So we control everything on the protobuf. It's not in this layer.
Okay.
Yeah, for schema things, we mostly tried that that we talk to business and have the master schema with place. That if they are saying that yeah this can change with Hoodie, it is little easy. Like, but Hoodie does not have that great schema evolution supports, right? So what we typically say that we try to talk to business and come up with the master's schema. If they are saying that that column can come, we'll simply insert it, even if it can be null or something. That's the simple. If they say that no, we don't know, then Hoodie does support some of the schema revolutions. But the problem with Hoodie and the BigQuery syncing is that you need to manually delete that BigQuery view, which is created after syncing Hoodie with the BigQuery. So if any schema is changed, our business need to communicate with us, and once they communicate, we take as a story point, and then we manually delete a view and we run the BigQuery sync again, and then it is done.
Yeah. Okay. So you talked about the whole pipeline here, right? Do you run any data quality check in this whole pipeline? If so, when do you run?
So as I told you earlier, we have the parallel table. So we always run the data quality check until the migration, and after started the double write both, the quality checks will be starting. The count will be checked 100% should match. If not, it will alert it. And once in a day, it will check the entire data, make sure both are matching.
Okay.
We have two different type of data quality check. In batch, it's very different. I will talk about streaming only, because streaming we have implemented Lakehouse mostly. So in streaming, if we start having data quality check in streaming, it becomes very, very tough. Because let's suppose your timing you are taking is 3 minutes or 2 minutes about your streaming timing. If you implement your data quality checks, it becomes really hurdles in the streaming scenario. Your timing will increase. So what we typically do, that we create our data quality things that we have done in our use case, and we give that data quality to our producers, those who are pushing data to the Kafka, and we ask them to implement it. So whenever they are pushing the data to the Kafka, we have signed the contract, like the data should be like that. But in streaming, I'm still not able to find better solutions of data quality checks, frankly. So yeah, that is the way we have implemented right now.
Okay. Are you using any data observability tools or just a manual?
Not right now. We are not using any data observability tool.
No.
Using.
Okay, that's good. So you kind of transition to the whole Lakehouse architecture here, right? So now, what are the notable improvement benefits that you've seen, like overall system design? So you talked about mutation, you talked about the speed. What is your overall impression with adopting the Lakehouse with the previous systems?
So the first benefit, the query performance. We grouped the data by tenant ID. So any queries with tenant ID filter sees 20x performance. Without normal queries, without tenant ID filter, it's 7x to, or stays up to same. That's the range we had the query performance. And the second thing, one of the data product which heavily query the raw data, that resource cost went down $1,000 per day. And then we have we have mutable capability right now. Any data quality fix or backfill, that the amount of time it takes very less compared to before. Yeah, that's all.
Two things I can talk. One of the biggest benefit I feel after using Lakehouse, in typical data engineering pipeline, I don't think there is much need of using any things like Cosmos DB, MongoDB or as such. There are many data pipeline which just uses Cosmos DB or MongoDB just to support partial update. Let's suppose that for now you are getting 4 columns, after that you will receive 6 columns, like this partial update will happen. And for supporting it, most of the pipelines will go for some NoSQL based solutions, and that is actually not needed. Cosmos is very, very costly, right? So we realized that we can do the same thing using Apache Hudi or any other open table format. That was the best benefits we got, because we simply removed all our Cosmos DB in one of the pipeline. After that we removed in many. So it's like the benefit with this Lakehouse is you are already having data lake placed, right, with your organizations. Everything is placed. It's just that you have to add one open table format which has the metadata associated with that. So frankly speaking, the cost, if you want to convince, will be very easier for you to convince. But if you are using external system in your pipeline like Mongo or something, so that was the first thing that we realized. The second thing is that whenever we are making upsert, there are chances that our business will also ask us to develop time series data, because they want to see that whenever the update is happening, what happened at that particular time. With this scenario, like you want to create your sync systems having time series, and that should also have upsorted data. You have to play data a lot, right? The first thing you will load data into raw zones, then you will create time series data on that, like append or something, and then you have to create upsert. With Lakehouse, you have going back, like looking back to the history with the upsorted data. So developer don't need to pinch their mind of developing two things, because most of the times time series are generally created for satisfying our end users. Like they will say that time series you created, we will use it after some times. Like some machine learning algorithm will run. God knows when that machine learning algorithm will run. But they will say that, yeah, you have your time series data and observed data. It becomes very pain point for us. With Lakehouse, it solves, right? And when we are solving it, we see that the cluster timing that we were taking to create time series plus observed data was 2 times more than what we used when after moving to the Lakehouse thing. So that was the major benefit that we have seen.
Okay, I have one question on that. Like how many versions that you will be storing in the upset side of it? Like, won't it slow it down? Like if you store more and more?
Yeah, it will slow it down. But for now, we just started. The good thing is the compactions. We have told that we will be maintaining near to one year.
Okay.
And the good thing is that we have not completed 1 year.
Oh, nice.
So yeah, but after that we need to write some compaction algorithms which will just compact and do the things. It is not that hard also in Hudi. So I think we will able to make it.
Okay.
So for us, we cannot store more than 7 days for GDPR thing. We need to hash it. That's why we store 7 days of version. And also we build table maintainer process, which will automatically, remove the old expired snapshot and then delete old version, those things.
Okay. With that, like one final question, like if anyone here looking to adopt Lakehouse architecture, what advice you would give to them?
Yeah, Lakehouse is essential. It solves, these are part of the problem we discussed, and also it's a lays groundwork for any advanced data advancement going to come in coming years.
One thing I can say, if you were software engineer, or if you are software engineers, you will simply like Lakehouse. So if you like, try implementing in your new use case. Whenever the new use case is coming and you know that you have to apply upsert, instead of making a migration project, start adapting in a new project once you do understand how Lakehouse work. So you can simply move your you can convince your teams to move out from data lake to. But I will still say that Lakehouse is not the solutions for everything, right? If you are having mutable data, then try Lakehouse. If you have immutable data, it's open. Don't over optimize it. Data lake is really good. Just try to see that if Lakehouse is fitting into that, and for that you have to read little bit, make your fundamentals clear. Once your fundamental is clear, you can use it. But never having this tendency that Lakehouse will solve every other things. No, it will never solve it. Keep your something in data lake, something in data warehouse, something in Lakehouse. Don't follow any trendy things just for sake of using it.
That's great. Want to share anything, Ramesh? Great. Yeah, with that we kind of control. We can take a couple of questions from the audience. Like if you have any one question, I have a question here. I have so many questions. I'll go and give this one so they can ask directly to you.
One chose iceberg and another one chose hoodie. So wanted to know why you chose a specific one and not others.
Okay, so
the iceberg and realize that we have to, it won't delete the older versions quite often, or we have to manually do it, and there is no single command which will delete the versions. If I have a multiple or very complex data, different data structures and all those things, how can you make sure that delete makes easy, or we have to keep running the delete job separately every time? Say for example, if I have 20 data sets, do I have to delete delete strategy for each 20 data sets?
yeah, so the one thing, iceberg has the command expire snapshot. They recently added to Spark store procedure that will help you to delete. But you need to build, as a data platform, you need to build the continuous running process to delete it. So we build table, we call table maintainer. So we need to run the table maintainer for all the tables in your data platform. So we set default 7 days. Anything 7 days, just delete it. If you want to overwrite during the table creation, the table creator will set, hey, for this I need to delete after 3 days. They override that property in the table properties, that the common component which take, honor that property and then delete only after 3 days. Yeah, you need to build that one.
Yeah. So my question is, if today given a chance to migrate to Delta format and Databricks, would you do that?
So I work for Branch. Branch is open source. Everything we have, everything open source system. Either Hoodie or Iceberg aligns for us compared to Delta. So the given chance, either I will go Hoodie or Iceberg.
Yeah, same answer. Yeah, we are just a developer. We have to get approval also, right?
I have one question.
Yeah.
So, basically, we have this thumb rule, right? Like, if something is running in production, don't touch it, right? So, we are talking very big POCs and all, right? So, I think 80% will have that fear. So, if I do something, what if something fails? So, that will come in my blame. So, how to prepare for that failures? So, we talked about all the successful things actually. So how to prepare and how to face that failures. Consider I am doing something and I'm failed in that. So where I was not able to achieve what I was planning to do.
Yeah, so I will give you one more story. My lead is there. His name is Neil. He's worked with Rapido. When I started my first job, he given me a very good advice. If you are afraid of breaking things, you will never become a good developer. And that I remember right from the beginning. Yeah, everything is working in production, it's very, very good. But we also have many different environment, right? Dev environment, stage environment. And if I'm afraid of breaking things in production, then what story I will tell to my children? I should break it. At least 2 or 3 should be broken, right? So, but you have multiple stages, right? Dev, then you have development, staging environment and other things. Test it. And if it breaks, then God knows. But yeah, means as a developer, frankly speaking, you should not be afraid. If you are afraid, it's very, very wrong thing.
I think I have one answer for you. There's a systematic process for handling those. Like the reason I was joking, like migration project or the career killer, right? Like, but there's a systematic process that you can approach. It's a simple project management strategy, right? If you are trying to do Apache Hudi, and then you want to implement, the first thing that you need to do is like, what are the things, like there's knowing the unknown, like what are the things that you don't know? List it out first and trying to figure it out, answers for that. Once, before, instead of jumping on to implementing the project, just first list out like what are the things that I don't know that I need an answer. The moment you started to get an answer, you will convert the problem statement from an unknown problem to a known problem. So always tackle the things that you don't know first. That way you make your project or your implementation more predictable in the later point of a time. That I'm following that for a long time. It worked very successful for me, so that's something I can share.
So I have a question here. Thank you, and it was very much informative. I'm talking about my use case. Maybe I'm seeking some guidance there. So we have a data warehouse which is 100 TB, which is Oracle Shop, and enterprise tools and business data very critical. And here, like we have staging layer. So we are trying to create kind of a lake house or data lake or some cheapest solution on premise, which can at least store the staging layer data, which is not accessible to users. At least we can store that, process that, and save our cost that we are bearing with Oracle storage, big storage there. So any suggestions that you have, how can we implement on-premise data lake or some cheapest staging kind of environment which is allowing us to process also, and then moving into the enterprise data warehouse?
Yeah, this thing I've only dealt once in a life. So for these things, what we typically do, we have that mode of historical load. If we want to try something, we have to load the data from data warehouse to our staging layer, and then we have to figure out the way that is this solving your problem or is it making your system more version. Like you should not always think about making it faster. If your data warehouse, it is in premise and it is cheaper and you are able to solve it, I think you can still go with that. But you really want to migrate, then try migrating some of the data to your stage environment. Go for some multiple POC, try to see if it is working or not. And if you feel that the cost is really decreasing, you are really beneficial, then try to migrate it. Ramesh, anything?
Yeah, so running, running Trino or anything table format, Hoodie and Iceberg is our open source. You can take and then run it within few days. It will not take much time. So when you say on-premise, are you talking about non-cloud thing or one data center? Yeah, you can run these systems, and already there are a lot of companies running on proven Trino or in a Hoodie running in the Uber. So yeah, so you can run easily those things. Sorry, I could not hear you. I use only MinIO for development, not in the production. I don't have answer, production environment.
Yeah, it's great. Thank you so much. Thank you, Ankur. Thank you, Ramesh, for sharing your expertise. Thank you so much.
Hey, thank you.